Thank you for joining us. My name is Eric Siebert and from HPE, and joining me is Bob Neal Jocelyn from 3Par Engineering and Julian Cates from Nimble Tech Marketing. And today we're going to talk about my favorite subject, which is VMware VVols. Before we jump in, I always like to ask at these type of events, who's actually using VVols today by show of hands? And that, well, it's good. That's encouraging. See more and more hands, the more VVols matures in that. So it's good to see more people are actually using that technology because there's a lot of benefits to it. Has anybody not heard of VVols or don't know what it is and that? We're going to cover some of the basics on what VVols is and then kind of deep dive in the replication component. So before we get to that, I just want to talk about where we've been and where we're going with VVols. VVols has been out for about 2.5 years now, part of vSphere 6. We've been actually a design partner with VMware on VVols development for over 6 years in that. So it's been a while since VMware initially announced this technology way back in one of the VMworlds in that. And with HPE and Nimble and that, we're both support the latest version, the kind of VVols 2.0, which is in vSphere 6.5. It supports array-based replication. And like I said, we're a design partner with VMware on this, so we're continuing our development as VMware continues to mature the VASTA spec and add more capabilities in there. So if we look at, why do we even need VVols? And that, isn't VMFS great? It works just fine. And that, why do we need a new storage architecture to begin with? I'd like to cover some of the hidden challenges that really help to highlight the benefits that VVols provides. One, with the current architecture, it's very LUN-centric, and we're pretty much creating these LUNs, pre-allocating storage, carving our storage array up into silos. We don't really have any visibility with block arrays into what's going on in that LUN. So we can't actually see and interact with VMs with VMFS. We have to do everything at the LUN level. We're always over provisioning storage and that to be able to support those LUNs and the VMs inside them. Administration's increased because we're always going back to the storage admin for something. Hey, can you snapshot this? Hey, I need more storage and whatnot, and dealing with all that LUN management increases the administration on both sides. Difficult reclamation because until vSphere 6.5, the only way to reclaim space, again, since we don't know when VMs are deleted or moved, is to run ESXCLI to go in there and chug through the array and try to reclaim space. So that's another manual process. Very hardware-centric, where we're using both the vSphere admin console and the storage admin console to do things separately, and that it's not really truly unified. You have to use plugins to get all that stuff into vCenter. Provisioning's longer, and then the big key thing here is our data services on the array. All the powerful features that we have are like snapshotting and replication, then provisioning, compression, dedupe, aren't aligned at the VM level. It's all done at the LUN level. So you can't get really granular with your array to kind of pick and choose how you want to apply those data services to virtual machines. So what are VMware VVols? So essentially what VMware VVols are is the storage architecture that VMware created, designed to essentially replace the existing implementations that we have around VMFS and NFS today. What they have done with VVols is with the VASTA specification, they've kind of designed it to support this VVols architecture, and essentially that outlines how us storage vendors have to design our back-end code and stuff like that to be able to do the capabilities that VVols provides in that. So essentially it creates a unified standard that all storage vendors have to adhere to be able to implement VVols. What it does is it enables vSphere now to natively write VMs to storage arrays. So before, what do we have to do? We had to either create VMFS volumes and then we could create files on those or just write files to NFS. Now with VVols, we can natively, the host can natively write virtual machines directly to a storage array without a file system as an object. And that essentially is a VVol. All the common storage management tasks that we normally have, like things like provisioning storage, things like creating snapshots, replication, whatnot, are all kind of automated now via vSphere storage policy-based management. It's designed to be very dynamic in that we're not doing any LUN provisioning anymore. And that all the provisioning of storage is all done automatically. There's no more creating, maintaining LUNs, resizing LUNs. Everything's dynamic and automated with VVols. And then again, the storage array features can now be applied directly to virtual machines via SPBM. So if we look at how VVols transform storage in vSphere from the current model with VMFS and NFS to VVols, we go from being very LUN-centric to VM-centric. There's really no more LUNs to manage. We're not siloing the storage array up with LUNs, and we're aligning the array services directly to virtual machines. We're going from being very static to very dynamic. Everything is reclaimed and provisioned automatically. We're going from a lot of complexity that exists today, and that using like vendor-specific tools to do our storage management, to very simplified using kind of unified management directly natively in the vSphere interfaces. And then we're going from a lot of time-consuming effort, kind of managing our whole storage environment, to being a lot more effortless, where we're not doing everything kind of provisioned instantly and automatically, and space is reclaimed right away as needed as well. If we look at, I like to always point this out, because what VVols does is really sets the standard for all storage protocols to adhere to, and that. So if you look today with VVols, or with VMFS and NFS, how things are done and what changes with VVols, because VVols kind of dictates how we have to do things, whether we're a block or file array. Our host adapters and IO transport don't change at all, and that's just done as usual. But things like our host present, how we're presenting storage to vSphere is a LUN with block storage, a mount point with file, and that changes to a storage container and that. So we're not having LUNs or mount points anymore. We're essentially, it's a storage container is a native entity that we're using to present storage to vSphere. File system, we go from being managed by vSphere with VMFS to being managed by, on the NFS side, it's array managed, so the vSphere kind of pushes the file storage management over to the NFS array, to becoming all completely vSphere native and that. So again, there's no file system with VVols. Whether you're a block or file array, you're essentially just writing, vSphere is writing data natively to that. We go from VMDK files to VVols. And then the storage visibility where, file current, or before VVols, file had a little bit of an edge where they could already see VMs and that, because VMs were being written as files on a storage array. There was no LUNs on a file array. But now with VVols, it makes that we get the same VM level visibility via VVols as well that you could previously do only with a file array. So it really kind of unifies and dictates a universal standard for storage now, and that no matter what protocol you're using, everything is essentially done the same way. So a quick overview of the VVol storage architecture. We'll be talking a lot of what kind of makes up VVols when they get kind of deeper into the replication components. First new object is a protocol endpoint, and the protocol endpoint is essentially a special LUN with block storage. It's a special mount point with file storage that has no storage provision to it. It's essentially kind of almost as an IO proxy, in that it's got a special bit set to identify it as a conglomerate LUN, so you can't write data to it like you normally would without VVols. And essentially that's my data path. So all the host connects that are connecting to the storage array to access VVols are all going through that protocol endpoint as kind of a single source to get to the underlying VVols and that. So that's essentially the data path. Then we got the VAS provider. Now the VAS provider is my kind of communication mechanism, my control path, where some of the information is passed back and forth from the array to the host to vCenter, things like what are my secondary LUN IDs and other information that are used there. The VAS provider can be either embedded within the array or an external component. Some vendors have embedded it within the array with 3-power Nimble. Ours are embedded within the array. Optionally, other vendors have implemented it as a virtual appliance and other methods for doing that. The storage container, and this is basically what exists on the array where my VVols are going to reside within the storage array. There's no storage really allocated or provisioned with a storage container like you do with a traditional VMFS volume. But essentially it's just my pool of raw storage that's on the array. It's more of a logical entity. You can create multiple storage containers on the array if you want to kind of subgroup your VMs in there. And then there's a kind of a virtual storage container that exists in vSphere that's attached or connected to the storage container that's on the array. The virtual volumes itself, there's several different kinds of virtual volumes that exist for each virtual machine. There's config VVols, there's data VVols, snapshot VVols, memory state VVols, and they're all there in different types. We're not really going to go into what those different types are and how they work, but every VM is essentially made up of several different VVols, which essentially are an encapsulation of various components and files that used to exist in VMFS. And the storage profile is what makes this all work. So the storage profile-based management engine that's in vSphere that was initially introduced with vSAN, also that same engine is used with VVols to be able to apply my storage capabilities directly to virtual machines. And this kind of gives you an overview of how that works. So what we're going to do on the storage array side is we're advertising everything we're capable of to vSphere. So whether it's something hardware specific, what type of drives this is, what my RAID levels are, all my array capabilities, all get advertised to vSphere. And then once vSphere is aware of these, I can now go out and build storage profiles and storage policies. And those storage policies are kind of, you can cater them to whatever your requirements are for those VMs. If you needed one to have, like a gold, silver, bronze one that has faster disks, better RAID, and better array capabilities, you essentially build out your policies. And once you have your policies, you then assign them to virtual machines, and then those virtual machines, basically SPBM keeps them on the appropriate type of storage that kind of satisfies the provisions in that policy. So, I don't see a lot of hands, like I said, that people are adopting VVols yet. So I think the more, and I see this a lot, is when we talk to people and explain why would you want to go to VVols, it really helps them to, hey, this is good stuff. I want to migrate to that. So I'd like to cover some of the, briefly cover the reasons why you'd want to consider VVols to begin with. The first is you don't have to go all in with VVols and that. You're not, you can run it side by side on the storage array with VMFS. You can go back and forth. So if you want to move a VM from VMFS to VVols and back, you can do that at any time. And that, it makes it easier to kind of ease into VVols and that. You're not pre-provisioning storage with VVols, so essentially if you have some space left on your array, you can put that VVol storage container there and then just grow it up as, whatever space you have available. Getting early experience in that, eventually VVols is probably going to be the only storage architecture available with vSphere. VMware never keeps two of anything around. You've seen ESX had died, the vSphere client is gone, they just announced vCenter, the Windows version is going to be gone. So at some point, VMware is going to deprecate it, and getting that early experience instead of waiting until the last minute to jump to VVols will help you make that transition later on when it's necessary to do that. Getting your disk space back, this is a real big one, I think, because you're staying very thin and efficient on the storage array. You're not pre-provisioning any storage. All my space is automatically reclaimed, so you're not having to go and run commands to try to reclaim space. So the array stays a lot more efficient when with VVols. It's available in all vSphere editions. This isn't a feature. This is a native core architecture, so no matter what version of vSphere you're running, you don't have to pay any extra for this. It's just there as long as you're running vSphere 6 or higher. Allows the array to do all the heavy I/O work and that. So essentially with VVols, things like thin provisioning, snapshots that we were doing in vSphere that was very resource intensive, all that gets completely offloaded to the array now. All my snapshots, all my thin provisioning, all those features are all done on the storage array, but they're managed in vSphere. You get to start using storage policy-based management, which is pretty cool. You can create those policies. It's a lot more effortless. You have your policies defined, just apply those VMs. A lot easier to manage and use your storage resources. Snapshots don't suck anymore, and that if you're familiar with snapshots in vSphere, they can really suck the life out of your environment, especially if it's been running for weeks or months and you try to delete one. With VVols, we're not actually, the way we do snapshots is completely different. So when you delete a VVol-based snapshot, essentially we're not having to roll data back into the base disk anymore like we have to do with vSphere and those Delta files. Essentially we just discard them because we're doing snapshots kind of in the opposite manner that they're done vSphere natively. A lot easier for generalists. You don't really have to be a storage admin with VVols because essentially all my management is done natively in vSphere. Not having to go and keep doing things on the array and go back and forth. So it's a lot easier that if you don't want to be a storage admin, you can pretty much do everything in vSphere. One architecture, like I told you before, essentially, this really levels the playing field between storage and block. So that those debates on, what should I use, NFS, iSCSI, fiber channel, it becomes a lot easier to, just use what you're comfortable with, and really simplifies block storage too, as well, because you're not dealing with LUNs anymore. And the big reason in that is, the VM is now a unit of storage in that. So essentially with block storage arrays and that, we can see those virtual machines, and this is what it's all about, is we can interact with those virtual machines and provide all of our array, based data services directly to virtual machines, and, we're not using LUNs anymore. So that's it. We're now going to deep dive on replication.
Cool. So as we introduce the replication deep dive, just want to go over a couple of quick bullet points. First of all, array replication support via storage policy. This was introduced in vSphere 6.5. That was with the advent of VASA 3.0. Just a quick side note, Nimble, if you're familiar with Nimble replication with VVols, we actually supported that in vSphere 6.0. So there's a slight difference there. The replication that was supported in 6.0 was completely supported by Nimble. What was added in 6.5 was the ability for VMware to control that array-based replication. So we'll talk about some of the Power CLI commandlets and some of the public-facing APIs, which were included in vSphere 6.5, and that is the differentiator there. I will point out that both of the HPE storage companies represented here today, Nimble and 3PAR, were the first two to complete VVol replication implementations. So I haven't checked recently, but I think the last time I checked, we were the only ones to have completed those replication certifications. So we certainly have an advantage there. I will point out that this is before the merger. So when you look at some of the interfaces, which we'll show today, things may look slightly different because we each implemented those according to the VMware spec, but in our own way. So we'll see things slightly take a different flavor between the two flavors of storage.
Yeah, and so Eric introduced me. I'm Bob Neal Jocelyn. I'm the architect and the engineer, so I'll get technical on you guys today. Hopefully that's all right. So just like everything else VVol, where VM was a unit of storage, it's the same with replication. So you have the ability to replicate individual VVols. If you're used to traditional LUN storage, it's a very complicated process of figuring out which LUNs are being replicated and how do I make sure that I fail over the right ones if I've got particular VMs that I need to fail over. With VVols, that's a whole lot simpler. You just simply say, this is a VM that needs replication, and it gets placed in a replication group. You have the option of creating those replication groups for individual VMs. They can be created automatically by the array, or you can also place them in pre-existing replication groups. It's up to the vSphere administrator. This really is a vSphere interface. You don't need to do a lot of work with your vSphere administrator to make VVol replication happen. Oh. Did I press the wrong button? Oh, I see. Excuse me. So, again, this is technical. I'm assuming a good percentage of you understand some of the detailed objects that you are used to inside of a vSphere environment. For example, VMs, hosts, data stores. With vSphere replication, with VVol replication, you're going to have a couple new objects. The first one here is called a fault domain. A fault domain represents an object that fails as a whole. Now, in the case of 3PAR, we represent a fault domain as a storage array with the concept of, hey, if this array goes down, we have to do failover for that group. With Nimble, it's a little different.
Yeah, on the Nimble side, that fault domain is actually going to be the Nimble group. So Nimble will have the ability to group up to 4 arrays together, so they're managed as a single unit, and we call that a group, and that's going to be the unit of the fault domain.
Yeah. And then replication groups, obviously, are something that you'll be managing now. The VM is a unit of replication now, so you're going to be able to place VMs in these groups. The groups maintain a consistent point in time. So in other words, if you place one or more VMs in the same group, those VMs will have the same point in times at the target site when the failover occurs. In other words, if you've made a modification to one VM, that VM's data will show up only when the same point in time modifications occurred at the other VM. One VM will not be ahead of the other VM during a failover. If you don't care about that consistency, you can just place VMs in different groups. In 3PAR, we only maintain the most recent point in time to recover from during a failover. It is possible in the VMware implementation to have multiple points in time, so you can go back in time and say, I'd like something from an hour ago instead of from 5 minutes ago. But that's something we'd be looking at future-wise. And with Nimble...
Yeah, on the Nimble side, what we've had prior to VVol replication, anytime we did array-based replication, that was always done at the level of what we called the volume collection. So a volume collection is essentially a group of volumes, and those volumes are snapshotted and replicated in lockstep with one another. So it made perfect sense to use that mechanism, the volume collection, as the replication group as well.
Okay. And when it comes to RPOs, one thing to note is whenever you make significant modifications to a replication group, that may stretch the RPO. For example, let's say you've got a VM that's already replicating in a replication group and you want to add a new VM to that same group. For whatever reason, you want consistency between those two VMs. And that VM already exists, and perhaps it's a terabyte of data. Maybe not that much, but a lot of data. That will take a while for that terabyte to get across, and in order to keep that consistency, be aware that you won't have a new consistency point until that terabyte of data gets replicated across. If you fail over while that's happening, your consistency point would be such that the second VM doesn't exist at the target site. So the other thing to note about groups is they can be in the source or target state. I would think those are kind of self-explanatory. Source is obviously where your VMs are running currently, where the master data is. Target is where the replicas exist. And then an in-test is a special state of a target group, which allows you to verify the integrity of the data at the target site. It's what happens is you take the VVol replica and make the replicas of the VVols, and you make copies of them. And then you can expose those to ESX hosts, and those can then be powered up at the target site just to verify everything's working correctly. And then finally, the failed over state, that's after you've had a disaster, or maybe a planned failover. Now that the replicas at that site are promoted to actual source volumes, after a failover, that's your go-to forward point. Anything in the source at that point would be overwritten when you reverse. So a failed over group takes priority when it comes to your data state. And just a little point of terminology, we use the terms source, primary, and protected interchangeably. Same thing with target, secondary, recovery. It's just all different vendors have different terms for the states of their groups. So that's a graphical representation of what I've been talking about. So first of all, these little circles are the individual VVols. The storage containers that contain them are these rounded rectangles. And you'll notice the replication groups are these ovals. And you'll notice that there are VVols inside storage containers that aren't being replicated, and there's also VVols inside containers being replicated. In those groups, they're consistent. The other thing that's very interesting and something very different from traditional storage is since we're not replicating the data store, we're not replicating the storage container, you can have replication going in one container and out of the same container at the same time. And again, it's the vSphere storage policy that controls all of this. So how do you get ready for VVol replication? We're starting to dive a little deeper here. It's actually very, very simple. There really isn't anything special required. Yes, you do need the latest version of vSphere 6.5, and really not much else. You register the VOS provider like you would have done with traditional VVol replication. You mount your storage containers, and you do that both at the target and source site. You could not do that before. If you had a replica data store on a traditional storage container, you can't mount it until it's failed over. You can have the data stores mounted at both sites before failover. And you obviously have to have a storage policy that requires replication. Again, Eric was talking a little bit about the policies a few minutes ago. One of those capabilities is the replication capability. So for 3PAR, again, nothing special. You just need to have our more recent OS release, version 3.3.1. You have to have our remote copy license. And then you need to connect those arrays together. And that's not anything different than you would have done for traditional replication. So in a way, it's simpler. And of course, you have to create those storage containers I talked about mounting earlier. And so for Nimble.
Yeah, on the Nimble side, As I mentioned earlier, you can actually do this with vSphere 6.0, but you're probably going to want to do it with vSphere 6.5. In vSphere 6.5, that's where, again, the VMware control of array-based replication was introduced. So it's probably the best option for you to go to. From a Nimble OS perspective, you're going to want to be on a version of Nimble OS that supports VASA 3.0. For us, that was introduced in Nimble OS version 3.6. As far as licenses go, there's nothing additional that you need to make sure that you have. The replication capability is going to be built into the array. So if you've got a Nimble array, you've got the ability to replicate data from that array. You do need to do some configuration. So on both your upstream partner and your downstream partner, you're going to want to make sure that there's a replication relationship set up between those two. So there's a little key exchange that goes on, and you just configure the two to replicate data back and forth to one another. And from a VVol perspective, you're going to want to create, we call them folders on the Nimble side. That's our analog to storage containers. So you're going to want to create those storage containers and turn them into VVol data stores on both sides of that replication relationship. And just kind of as a side note, there's some ability there to sort of name those folders the same thing. That from a replication relationship standpoint, that's going to make sure that you get the data replicated from a specific folder to another specific folder. Naming them the same and checking the box that says put these in the, the name that matches if possible is going to be the easiest way to make sure that that happens. So here's a walkthrough of actually creating that Nimble folder. Again, we use folders for a couple of purposes. VVols happens to be one of them. We could just use those for general purpose organization, but as soon as you go in here and select what third-party management type you're going to want to use with that and select VVols from that, then that's what turns that into a storage container and for use with VVols replication. You do have to set a capacity limit for that, and you can optionally set at that folder level, so again at that storage container level, a QoS limit so that you can limit, if you're the storage admin and say you're handing this storage container over for your VM admins to use, you can use, or you can put some limits both in terms of capacity and performance on that. So you do have the ability to kind of keep some checks and balances in place there.
Okay, so it's all text, but it's kind of the key takeaway slide here. First of all, some of it we've already mentioned. VVol replication is granular, meaning it's per VM. It really empowers the vSphere admin to decide what needs to be replicated, what doesn't need to be replicated, and the vSphere admin is allowed to perform the failovers. There's no need to coordinate with the storage admin. The VVol replication is enabled by adding that storage policy. vSphere in 6.5 introduced this concept called a SPVM component. You can create replication component with replication constraints and then apply those components to different policies. So for example, you can have your gold, your bronze, your silver, but use the same replication policies for all of them if you want. And as Eric mentioned, it's true with traditional capabilities. SPVM maintains compliance to ensure that those VMs are being replicated. If something happens with replication, the connectivity is down, we'll generate alerts. The array will generate alerts. vSphere will generate alerts. You'll be able to verify whether your VMs are compliant with replication or not. So this is what an example storage policy looks like. This is specific to replication. And so it's broken up in a few parts here. The first part is that we have the ability as a replication capability to choose which storage containers we would like our VMs to show up in at the target site. It can be different arrays and different storage containers in the array. So the local administrator of the local VM says, yeah, I need this to go to that particular location. You also have the ability to choose some of the drive characteristics used at the target site. For example, you can choose the tiering for both the base volumes and the VM snapshots. For example, place the VMs on flash drives and place their snapshots on traditional fiberglass drives. You also have the ability to select what kind of remote copy operations are available. In our case, the only thing we support today is periodic replication. So in other words, every 5 minutes, every 10 minutes, we make sure there's a consistent point at the target site. And then you have the ability to decide what are the acceptable RPOs for your VM. And if you set this range, then only the replication groups that are currently meeting that RPO would be available for replication. Now you might ask, well, what about all these other VM capabilities we talked about earlier, like deduplication or compression or some other features? Where possible, with repar, what we do is we replicate that capability to the target site if the target site can support it. And if not, then we'll fall back to a lower class of service. So with Nimble.
Yeah, Nimble storage policy, as you can see, it's sort of the same interface because this is, again, sort of homologated through VMware. But you can see that it's slightly different. So here, what we're looking at is, first of all, we're going to set a protection schedule. Here's where we can choose, a minutely schedule, a hourly schedule, a daily schedule, a weekly schedule, and put that in place and put a, choose the days of the week, choose the hours of the day for which that policy is going to be effective, and then how frequently we're going to take those snapshots. You can set both the local and the remote snapshot retention policies through this SPVM policy. So you can say, these are the number of snapshots I want to retain on the source side. When I do my replication, I want to keep X number on the destination side as well. Here's also where you put the replication destination in the policy. So I could have, I've chosen a specific storage array here. Say I've got a storage array in Phoenix, so I've got another one in Chicago. In the Phoenix data center, I would put in my storage policy, replicate to Chicago. And every VM that got that would automatically have its VVols replicated. And then lastly here, we've got the option to delete or not the replicas once the source is deleted. So we might want to keep those around to do some recoveries from later on down the road, or we might want to go ahead and just delete those to recover the space. That's completely up to you.
So we're going to dive down a little deeper now. We'll get into what it's actually like to replicate a VM. So if you're creating a new VM, it's as simple as selecting the storage policy here. Let's see here. There it is. So you select the storage policy right up there. That policy has to have replication constraints. And then once you do that, remember I said, well, you can put it in a new group or an existing group. Well, this drop down, you see in the red rectangle there, that shows up when you choose a policy that requires replication, and you have the option of choosing an existing replication group or creating a new one. And when it comes to existing VMs, if you want to start replicating them, it's as simple as changing the storage policy on them. So you just take the VM, select Edit VM Storage Policies, pull that drop down, select a policy that requires replication, and then you'll see this configure button show up that says, here, you need to define replication groups for this VM. And again, you'll get that drop down. You can choose to automatically place the VM in the automatic group, which means create a new group, or if there are existing groups, you can place it in an existing group. And you also have the ability to do this on a per data disk. Now, it's much easier to recover your VMs if they're all in the same policy, all in the same group. But if you, for whatever reason, for example, have an OS that needs an RPO of a day, but your database needs an RPO of 5 minutes, it's possible to put those two different disks in two different replication groups. So what does it look like when you're replicating VMs from the 3-par array side? This is our CLI. So I apologize for kind of the eye chart test. And this command generates such long output, we actually broke it up onto 2 segments here. But anyway, what you can see here is the VMs that are being replicated. And so, for example, we have VM2, sorry, I'm too shaky. VM2 is being replicated. It's in the primary mode here. VM San Jose is being replicated in the primary. But we also got some VMs here, VM3 and VM Fremont, that are actually coming in from some other array into this storage container. And this is just a screenshot of our SSMC. It's our GUI interface. You can create storage containers, and you can view and verify what VMs you have and look at the volumes, take a look at how much I/O is occurring on the particular disks for VMs. So for Nimble.
And you can monitor the Nimble connection status as well. So here we're looking, again, specifically at volume collections, and these volume collections correlate to one of the VVol relationships that we've got set up here. We've got a couple of volumes that live in there. You can see the data and the configuration VVols for those. So you can monitor those directly in the Array UI as well.
Okay, so now one level deeper in technical. We're going to get into Power CLI level technical details, but it'll be very graphic. So first of all, this is an overview. We're going to talk about disaster recovery. We're replicating the VMs now. Let's do disaster recovery. So first of all, what are the things you need as part of this? Well, obviously you need 2 sites. Those 2 sites should have vSphere instances. They should have their own arrays, and of course you have to have your VMs and your VVols. So that's what we're showing in this graphic. But in addition, you need something to manage and orchestrate the failover. So there's that middle component there, the DR orchestrator. In our case, it's the Power CLI. That's the first interface available to manage disaster recovery with VVols. And so we're going to get into details on that. So what are the type of disaster recoveries? You're probably mostly familiar with these if you're here, but let's talk about it quickly. Planned failover is when you know when everything's running normally, but you just want to make sure you might have resources that are being overcommitted at the local site, and so you want to move them to a remote site and run them temporarily at the remote site. Or maybe you know something's coming and you want to get at least some of the resources off. That's a much more controlled environment.
Data center migration.
Yep. And the unplanned failover, obviously something bad happened. Power outage might be your most common case, could be worse. Could be a fire or a flood, as what's happening right now. So in any case, in that case, you typically don't fail over individual VMs. You usually fail over everything that was on the original array or arrays. And then, of course, test failover is actually not really a failover. It's just the ability to take those replicas at your target site, expose them to ESX, and verify that the VMs come up, everything looks fine, the data's there. So planned failover, I'm going to walk through in detail the Power CLI. If you're interested, and then for unplanned failover, we got a quick demo video. And then if you're interested in test failover, I'd recommend going to the Virtual Blocks blog. We've got it kind of details on a test failover, including demo video. Okay, so for Nimble, we have.
Yeah, so with the latest version of Nimble OS, we've introduced some increased level of interaction with VVols within the UI itself. So there's some things that you used to have to do via command line that you can now do directly by the UI. I'm not going to go into a lot of detail on the snapshot-based recovery of local VMs, recovery of individual local VMDKs. But one thing that we will talk about quickly is the ability to do remote VM recovery. So this is VMs that have gotten a recovery relationship. Independent of this, the Power CLI and the public API-based failover that we're talking about here, we can actually use the vCenter plugin UI to scroll back, find a particular VM that's been replicated, find a particular recovery point that we're interested in, and then to quickly just click a button and create a clone of that replicated VM and bring it up on our remote site. So we do have a demo of that. I'm not sure if we'll get to it due to time, but I would invite you to come by the booth, the HPE booth, and we can show that to you in a lot of detail.
Okay, so this is a detailed explanation of a planned failover from the VVol level. So this is the situation. We got 2 VMs replicating from the local site to the remote site, and another one at the remote site replicating back. We're going to do a planned failover of the VMs 1 and VM 2 from the local site. So first of all, to explain, VM 1 here is represented by these VVols. Some of the VVols are in the replication group. One of them isn't. That's the swap volume. There's no reason to replicate swap volumes. And VM2, same thing. And so just to show, we've got replication going from the local site to the remote site for VMs 1 and VM2. They're currently powered on. And the one thing I wanted to point out is you'll notice that I've got these volumes in gray, these are the replicas. From vSphere's perspective, they don't even know they exist yet. The storage container is still there, but vSphere can only see that VM3. They can't even see these volumes. They will not become visible until a failover occurs. So, how do we do this? Well, we're talking Power CLI now. So the first thing you're going to want to do is discover information about your replication groups and the VMs associated with them. So there's this API called get replication group and get replication pair, which helps us identify what are the VMs in my replication groups and what are the target groups that I need to perform the failovers on. So that's what we did there, is we just discovered information. We found VM1 and VM2 are associated with that first group there, and we know the target group that needs to initiate the failover. Once we do that, this is a planned failover, so we're going to stop the VMs. Notice the swap volumes disappear with VVols. We'll do one final sync just to make sure we have the most recent data. And now we're going to do the failover. So start SPVM replication failover. You issue it on the target group, the ones with the gray volumes. And what will happen is the target group will become a failover group, and those gray volumes will immediately become visible to vSphere. The output of this SPVM replication failover is the file paths to those VMs. You would use those file paths to those VMs to register them in vCenter. So you'll do a new VM, they'll show up at the target site. And then once they're replicated, because vSphere knew nothing about them, when they appeared, vSphere doesn't even have a policy associated with them. So it's important to assign a policy to those. It's not absolutely required, but it's important if you want to reverse, to apply a policy that says, hey, these VMs need to replicate back to the original site. So what we'll do is we'll take our replication policy that replicates back to the original site, we'll apply it to those VMs. And at any point now, we could power up the VMs, we could remove the VMs. It's a good idea, especially in a planned failover, is to remove, or in this case, unregister the VMs from the source site, because anything that happens at the source site now is going to be lost when we reverse. Once failover occurs, the secondary site is the master of the VM's data. So we'll remove those VMs. The volumes will still be there. And by the way, if you try and remove the volumes, we have mechanisms to keep the actual data protected. So in other words, you wouldn't lose anything. So at this point, you can start your VMs at the secondary site, and you can also begin reverse replication. When you do the replication reverse, then those volumes that were visible at the source replication group disappear, and the source replication group now becomes a target replication group. So that's an example of a planned failover at an API by API level. So let's take a look at an unplanned failover. About 5 minutes here. I think it's best if I do it from here. Let's see. Okay. So what we've got is 2 VMs here and 2 sites. What I'm calling them is the Fremont site and the San Jose site. So we have VMs 1 and VM2. VM1 is being replicated now, but VM2 isn't yet replicated. So right now we're looking at the San Jose site. And, excuse me, because it's hard to get the timing on these videos right. Now we're looking at the San Jose site. We have another VM here, VM3. This is kind of similar to the presentation, but this is an unplanned failover. So I mentioned VM1 is replicated, VM2 is not, so I wanted to just give an example of what it looks like to take an existing VM and replicate it. So again, we select Edit Storage Policies. We select a replication policy that replicates where we want it to go. And you'll notice that this configure a replication group icon will show up here, or button, excuse me. And then you can choose which replication groups you want to use. And we could create a new group for this VM, but for this demonstration, I decided why not just do consistency and put 2 VMs in the same group. So, behind the scenes here, I wait a few minutes just to allow the VM to sync. And I wanted to graphically show what's happening here, because what I'm going to do is pull the plug on this primary array. So everything's fine with VM1 and VM2 right now, but I'm about to pull the plug. I did the final sync. Behind the scenes, I did that. And I'm about to pull the plug. So the plug has been pulled. And at this point, these VMs are going to become inaccessible. So we'll wait until that happens. Takes a second here. And so yeah, they're inaccessible now. So at this point, we really do want to fail over so we can bring those VMs up at the target site. And again, a little bit of pause here while I fiddle with the array. I'm making sure that the array stays off while we're doing this. So here's something I wanted to point out. Again, this is all Power CLI. What we've done here is created some scripts for Power CLI that perform these various types of failovers. And as part of the blog post I mentioned earlier, we make those scripts available as sample scripts for you guys to use. We try and make them as functional as possible, but something that you can build on top of it. They're definitely something you would build on top of. For example, if you have deciding which ESXs are going to run your VMs, there's kind of some shortcuts in this code. You might want fancier code to decide what ESX is, but it is pretty automated. So anyway, we're going to run the unplanned failover script because we don't have access to the primary site anymore. We need to run the unplanned failover. So let's let that continue. So what is the input to this script? Well, it needs to know what site has failed. So in other words, we talked about the fault domains earlier. So it's array S932 has failed. So we have to provide that as input saying, this is the array that failed. And this script is then going to go out and scan the remaining environments to figure out which replication groups need to be failed over. And because I didn't actually store anything ahead of time, it doesn't really know much about the environment, but it says, hey, I at least found you this replication group that needs to fail over. So we're basically going to fail it over, and that's the failover. It happens pretty quickly. And then the output of that, and I want to make sure I highlight that, the output of that is these 2 VM file name paths, these VMX files. That's what you pass in to new VM to register those VMs at the source site, at the target site. And then again, I mentioned you should apply a storage policy to your VMs so that they can replicate back. It's not a must, but it's a good idea in order to continue replicating. So we're going to register those VMs. We're going to take the file name paths and register them, and then we're going to apply the storage policy as well. And so the VMs are registered and failed over at this point. So we'll now switch over to the secondary site, the backup site over here, and we can, if we do a refresh, we'll see those 2 VMs show up. And I'm just going to power them up just to verify everything's okay. One thing I would mention is this is an unplanned failover, so this is as if the VMs had crashed. If the VM was running at the time, then it would be as if it's crashed. So yes, here's one of the VMs coming up. So far, so good. And this is what I expected to see. It's not very exciting. But yes, my VM is up and running, so I'm satisfied. At this point, let's say that, well, I'm going to shut down the VM. But at this point, let's assume that we've recovered our resources at the original primary site. It's time to replicate back. So when we did the failover, we identified what replication groups we were failing over. It's a good idea to take that information and save it off someplace. And so that's what we're doing here after I power things back up. So the script that we're providing, these sample scripts, they actually do save that information off. And then you can run another script that does a reverse replication. And what it will do is say, well, which failover event are you interested in recovering from? It reads that information, so where it's this last failover event at the bottom here. It reads that information in and says, okay, well, it's these replication groups that need to be reversed. It knows what VMs exist there. So what it does is before it fails over, it makes sure that the VMs that were at the primary site are unregistered, because we don't want people to try and modify them when we yank the volumes from underneath them, and then we do the reverse, and that's it. Did you want to get to yours?
So actually, I think we're going to skip the Nimble demo here. A couple of things that I would point out is that for this type of operation, where we're doing things through PowerCLI, or whether we're using the public APIs, the steps are all the same from the VMware side. So if I were to show you a Nimble demo, it would look pretty much exactly like that 3-part demo. But the other demo that we were going to show, but I apologize, we're just going to run a little late on time, is showing things from a little different perspective. It's outside of that PowerCLI framework. It's done within the Nimble UI. And I will be more than happy to personally show that to you if you stop by the HPE booth, and I'll run through all those scenarios for you. So please come see us there.
We want to give you plenty of time for questions too. So.
And one thing that you may not have noticed, but the reason why we're doing a lot of this in PowerCLI is SRM today doesn't support VVol replication and that, so you can't go and use those tools that you would traditionally do to set up all your replication and you'd be able to control failover from a GUI. Now, at some point, VMware expects to support SRM with VVol, so this will be a lot easier. Instead of using scripts and things, you'll be able to do it in a more kind of GUI and automated fashion. Quick slide on, with 3PAR and Nimble and that kind of our advantage in that. We've been doing this with VMware as design partners for quite a long time, and 3PAR is a fiber channel reference platform. So we have fairly mature implementations of VVols. Our VAST providers are embedded, so there's no really failure points external that can impact your VVol environment, and there's really nothing to install. Doing some innovative and efficient things around snapshots on different tiers, having very small capacity VM footprints, and being able to manage VMs or VVols folder by folder with Nimble, and then being able to use a lot of the storage array features and apply them directly to virtual machines, and be able to do a lot of the management inside of vCenter. If you want to find out more on that, we were showing, we have the demo that he can show you down at the booth. Julian will be down there, and we have a 3PAR expert down there too that can talk VVols with you. There is a hands-on lab out there too that if you want to try this in real time and be able to see how this all works, it's featuring on the Nimble array that's available that both during VMworld and I think after, and that via the VMware hands-on labs that you'd be able to experience that. We are doing a partner panel tomorrow at 4 o'clock. It'll be representatives from various storage vendors, Dell and NetApp and us, and then the VMware VVol product manager will be there. So if you got any questions you want to ask us with there, that'll be another opportunity to do that. And then we have some in-booth sessions, and that I think Julian did one today, but we got Pete Fletcher, one of the tech marketing guys from VMware, talking about VVols tomorrow, and I think Julian will be doing another session there. We have the schedule down there that you can see. Stalk us on Twitter. We talk a lot of VVols on Twitter, at least I do, and that. So, and if you want any questions afterwards, and that, I'd be happy to take them as well, and so would Julian. We have some DR scripts, so we've pre-built some scripts, and if you go to VMware's vSphere, VMware's VirtualBox blog about a week or two ago, we posted how to do a test failover with a demo video and the scripts that we use to be able to do that. So instead of trying to build your scripts from scratch, we have some things there that can get you started with that, and you might need to tweak for your own environment. We have some stuff on our Around the Storage Block blog, and some documentation on both the 3PAR and Nimble that will kind of guide you to using VVols and cover a lot of the benefits. So wanted to open up the questions, whether anything related to VVols and that, feel free, you can either come up to the mic here or whatnot, and we'll do our best to answer.
So what's the gap, since now you said in vSphere 6.5, finally vSphere has control of the replication. So obviously, what's the gap to get to an SRA where SRM can handle the orchestration? Because that's what everybody would want.
Yep.
And that's why people aren't using VVols, is because VMware advertised that VVols weren't supported with array-based replication, but they are supported with vSphere replication, with SRM.
Yeah, and I encourage you to take that to VMware because I think they're looking for
I
people
asked
to
that,
say this.
I asked that to Michael Dell last year at this conference.
And I know we specifically had this conversation with VMware last week and so they're looking for us to provide customer want to and that. So yeah, I appreciate the feedback because we definitely want to push on VMware to deliver that because that definitely is going to make this a lot easier for customers to use. So so hopefully, at some point, I think they are working on it currently, but how soon it comes out is really up to VMware, and we'll try to pressure them to.
And I guess to be clear, VVols can be taken advantage of. Everything you said about VVols can be taken advantage of with SRM with vSphere replication. They're all compatible. It's just the array-based replication and the SRAs aren't compatible. The SRAs and whatnot communication. I thought that would be fixed with VASA 3.0.
So we do work closely with VMware, and basically, yes, we're going to hound them too.
Yeah, we want it too as well, so we're definitely going to try to push on them. And I encourage you guys too, if you give your feedback to VMware, that'll help too get this accelerated. Next.
I'm going to presume the answer is no, but on the plan failover, you took your blobs and replicated them over, made them live. When you failed back, those actually went away. Is there any way you guys can either Nimble or 3PAR, and I actually run both, to use like CBT or something? So let's just say you did a plan failover for 4 months, and then we're going to go back to the original site, and we've got 150 terabytes of stuff that I don't want to replicate across the WAN link. Is there some way to use CBT or something like that so that you can actually put a delta on there, some sort of marker? It's kind of a dumb question, so I apologize.
So if I understand correctly, if you failed over and the VMs, the groups are still there, then the reverse will just replicate the deltas.
Okay, so you can do
yes.
that. Oh, good. Okay.
Yeah. No, there's no full replication. Only time full replication occurs is when you add a new object into your replication group.
Okay, so you're just putting the deltas back if you go back after 3 months?
Yeah, it's delta. It's definitely quick. Yeah. All right. No, the answer is yes.
I'm very happy to be on that. Thank you.
2 quick questions. First of all, you talked about the replication groups, and you mentioned the fact that they're consistent together, etc. It sounds a lot like consistency groups. Is that what's running in the background?
So the data is replicated consistently, and what that means is that we take a point in time, and then we make sure that entire point in time is replicated to that remote site. And not only is it the data is point in time, but the management of the group is point in time. So for example, if you've added a new VM, but that consistency point hasn't made it over there yet, then you won't see that new VM until the next consistency point comes along.
Okay.
So, yeah.
And second question, what about application consistent snapshots that you want to have them in the DR? Some applications don't recover that gracefully from a crash consistent backup. How will that work in that scenario?
So are we talking multiple VMs or just a single VM?
Usually it's a single, it's per VM.
So if you've taken snapshots of your VM-based VVols, those snapshots will exist at the remote site. So you can recover from the VMware snapshot at the remote site.
Yeah, that's easy. The question is how do you get them to be app consistent?
Yeah, so one thing I will add is that at least on the Nimble side, what we've got coming out is VSS support for VVols, so that you can take your application consistent snapshots and the array-based replication will replicate those consistent states.
Yeah, it's getting them consistent on the primary that's a challenge.
Exactly.
All right, thank you.
Yeah.
Probably got time for one more, and then we'll still be around after and that to take questions, or hit us up later at the booth too. So.
Do you have anything on the roadmap for synchronous replication, more specifically peer persistence and metric?
All the time, man. It is roadmap.
Stretch clusters.
Yeah, it's coming, and that we came out with async first because it was a bit easier to get out the door, and it'll be at some point we'll have that with 3PAR. We get that request often.
In the future, especially for HP, are you guys thinking of providing replication, whether it's VVol or anything else, between Nimble and 3PAR? Let's say a customer is already 3PAR customer and they want to purchase a Nimble storage for a DR site. And can we provide within a year, 2 years, a VVol-based replication or array-based replication for other stuff as well?
I can say that we do have a close working relationship with our peers at so I'm the HPE side at Nimble. We're too new to be able to address a question like that. But I think it's a valid question and something that we will look into. Okay. Thank you very much.
Thank you for coming.